Hi, I'm Anil Seth. Welcome to Neuroscience Support. My BF and I just watched that episode of Black Mirror, which is fantastic, isn't it? Where they have a device that can harvest your memories, kind of like in Meet the Robinsons. And it seems hella advanced, but can we now implant fake ones? The future is now. WTF. Can we implant new memories? This is possible, I think, in some limited way. We can implant new memories. Our memories are just very unreliable. People can reliably misremember what happened if they're told a plausible story. But we can also do it more directly. Hypnosis is a powerful technique. It's not just some stage trickery. Hypnosis is real, and through hypnosis, you can induce false memories. Watching a ton of 90s music videos today, and I'm wondering where in my brain I've stored all of these really non-essential lyrics, and if I can clear that space with something useful now. I don't know what's non-essential about 90s music videos. That's a central part of my own personality for sure, so I don't want to devote that space to anything else at all. But it's a really good question. How do we store? We seem to be able to remember an enormous amount of information. The adult human brain has about 90 billion neurons. It has about 1,000 times more connections, which means that if you counted one connection every second, it would take you about 3 million years to count them all. There's a lot of connections in the brain. And if you think that a memory is just a particular pattern of connections distributed among a large number of neurons, the number of memories that you could potentially store in a brain is infinite. Bohemian my ass. Is it possible to punch yourself in the brain so that you just forget certain memories and stuff like that? I wish it was. Actually, forgetting is very adaptive. It's very useful. It would be terrible to remember everything. In fact, some people with really, really good memories have a lot of problems in their lives because they simply can't forget. So is there a way to just get rid of particular memories? And we're not quite there yet, but there's some interesting work in just with mice at the moment that shows that it is possible to eliminate certain memories from mice. Whether that will also apply to humans or not is a long way down the road. But don't punch yourself in the brain, that's not going to do it. It says old people thinking that millennials use social media because you get a hit of dopamine when you get a text. Do you know how neuroscience works? Dopamine, this chemical in the brain that's often associated with rewarding stimuli, it means that many things can be rewarding. It's not just a bit of chocolate. So does a tweet or a Facebook update, does that really release dopamine in the brain? It's a pretty good guess. If we find something like that rewarding, that will involve the release of dopamine. Stefan Conrath asks, is it possible to read our brain? It's becoming possible in the sense that we can record activity from the brain now using a variety of different methods. We're not in some weird science fiction scenario where I can point something like a hairdryer at your head and know exactly what you're thinking, but in a more constrained situation where the kinds of things that you might be perceiving is restricted, then yeah, we're beginning to make progress. And another way this is really helpful is we can begin to read from the brain movement intentions. And this can be extremely helpful for people with paralysis because we can start to build what are called brain-computer interfaces and use signals directly from the brain to control arms or control robotic limbs. And this is a great example of why brain reading is still quite limited. On the left, there's a duck, and on the right, there's a reconstruction, and it doesn't look that much like a duck yet. Actually, and this guy, Yuki Kamitani, he's one of the world's leaders in this area, actually. So Kamitani, actually, he's done some brilliant work on decoding people's dreams. Because if you can decode the brain while people are awake, you can also apply the same algorithms while people are dreaming and begin to generate all these weird patterns of what the perceptions are that the brain might be generating while you're dreaming. KT80K asks, is there a part of the brain that senses a bad decision and tells you not to do it? Because I don't think I have that. This is a great question. It gets at one of the central issues in neuroscience, which is free will. And there are different parts of the brain that are involved in the execution of voluntary actions and in the inhibition of voluntary actions. There was a very famous case. A guy called Phineas Gage in the 19th century was working on the railroads, and a huge piece of metal went straight through his frontal lobes. The first miracle was that he survived. After he recovered, he seemed to be fine. But it rapidly became clear that he'd lost all his ability to monitor and control and withhold his actions, and he started behaving very inappropriately. What happened to him was the loss of the part of the brain that helped exactly this question, that senses a bad decision and tells you not to do it. We've all been told to take a deep breath when stressed. So what is the neuroscience behind why this quick tip helps so much? Well, there's a simple answer to this, which is that the brain needs a lot of oxygen to function properly, so if you're a bit starved of oxygen, taking deep breaths help. But there's also a more complicated story, which we're only as neuroscientists beginning to unravel. We've known for a very long time now that decision-making, doing the right thing at the right time, is very strongly shaped by the state of our body at a particular moment. And we call this emotion in another way. So we won't make the right decisions unless we have the correct kind of an appropriate emotional response as well. But sometimes our emotional response can be too overpowering, and then we'll make wrong decisions. So taking a deep breath might just readjust this balance between what we're thinking, what emotions we're feeling, and the state our body is in, so that our brain activity and our body can become more in alignment. Is face blindness a real thing or just an attention-seeking thing? It's a real thing. There's a condition called prosopagnosia, which is the inability to distinguish between faces. What you find is people with prosopagnosia, they're still able to identify people, but they do it in different ways. They're very good at picking up other cues, like how somebody walks or what clothes they're wearing or what voice sounds like, but they just cannot recognize faces. When you dream of things that you've seen and thought about and all that. So my question is, do blind people dream? And if so, how? Good question. Yes, blind people dream. Everybody dreams. In fact, it's not only humans that dreams, pretty much every animal with a brain, at least with this kind of cortex, dreams. Blind people, if they've been blind from birth, maybe they won't have visual content in their dreams, but they'll certainly have dreams very rich in other perceptual content. And nobody really quite knows what dreams are for. One idea is that when we perceive the world around us, we have to use these very, very complex models inside our head about what's out there in the world so we can interpret all the sensory data that's coming in. And when we dream, we're basically sharpening and improving those models so that they work better the next day. Arancha asks, can my amygdala light stop? I wish it could. The amygdala is a walnut-sized piece of the brain very deep inside the base of the brain here. The amygdala is very heavily involved in fear and anxiety, things like that. Without a properly functional amygdala, we wouldn't be sufficiently scared of things that should be scary. So when we were evolving in the African savannah, as early humans were doing, probably the most important thing is to be scared of the right things at the right time. And you need an amygdala to do that. Do you think transcranial magnetic stimulation treatment could alleviate PTSD, post-traumatic stress disorder, panic anxiety, or Alzheimer's? Now, transcranial magnetic stimulation, TMS, is a relatively new method, and what it does is it just injects short but very strong pulses of electromagnetic energy into the brain. It's not very precise. You can activate one part of the brain. For instance, I could activate the parietal cortex here or the frontal cortex there, so it's pretty non-specific, and the long-term effects are not very well known. It may be a technique which, alongside many others, will help us refine new approaches to these conditions, but by itself it doesn't provide any quick and easy answers. How does memory work? Will it be possible to surgically manipulate specific memories? How does memory work? This is a huge question. One thing is there's more than one kind of memory. Different parts of the brain are involved in these different ways of remembering things. To say that we understand how any piece of that puzzle works would be an overstatement. But let's just take one. Let's take autobiographical memory. How do we remember things that happen to us specifically? Now, this depends on a very specific part of the brain called the hippocampus. The hippocampus is very deep inside the brain. It's part of what's called the medial temporal lobe. The hippocampus seems to take in perceptual information as we walk around, as we move around the world, and then it consolidates these memories back out into the rest of the brain, into the cortex. So it's involved in the laying down of new memories. The memories aren't stored in the hippocampus, but we need the hippocampus in order to lay down new memories and in order to recover old memories. If you have damage to the hippocampus, you will not be able to lay down any new memories. You might still be able to learn a new skill, but you will not remember what happened to you while you were learning that skill. Vu asks, how does fMRI work? This is a fantastic question. In fact, it's a question I wish most neuroscientists would ask themselves again, because many of us assume we know how it works, and we still don't really fully understand what it does. Now, fMRI is functional magnetic resonance imaging. It's probably the most common, the most popular method of brain imaging. Put very simply, what fMRI does is it measures the amount of oxygen in the blood in different parts of the brain in a very, very precise way. And this is important because bits of the brain that are more active, where the neurons, the brain cells, are firing a lot, they'll consume more energy. And so the blood in those parts of the brain will have a bit less oxygen. So we can tell how active a certain part of the brain is by looking at how the oxygenation levels change. And in fact, it's still a very active area of research to figure out how that signal of oxygenation actually relates to neurons firing. Neuroscience says doing this one thing makes you just as happy as eating 2,000 chocolate bars. What is it? A smile. One of our main sources of pleasure in the world is social bonding. So whenever we feel that we're getting some recognition or some affection or some positive response from another human being, then we're going to feel a lot better. Whether it's exactly the same kind of pleasure that we get from eating a chocolate bar, I don't know. I don't generally feel guilty if somebody smiles at me in the same way that I do if I've eaten a couple of chocolate bars on the sly. Now, I hope I've been able to answer some of your questions, but the great thing about neuroscience is there's so much more to discover. This has been Neuroscience Support with Anil, Seth.